A literal equation is an equation that contains one or more variables and requires solving for one of the variables in terms of the others. When solving literal equations, there are several precautions to keep in mind. Here are some considerations. Check units. Confirm the units of the variables used in the equation and maintain consistency. Inconsistent units can make it difficult to correctly solve the equation. Avoid division by zero. Be cautious not to introduce zero as a denominator, as it can lead to undefined situations in the equation. Accurately record each step. Record each step of the equation solving process accurately and perform calculations correctly. Incorrect steps can yield incorrect answers. Isolate variables properly. When solving for a target variable, isolate it from other variables correctly. Review and test with simple examples. After solving the equation, review the result and test it with simple examples to ensure that the equation has been solved correctly. Consider constraints. Some problems may have constraints on the variables. Consider and account for these constraints when solving the equation. Multiple solutions. Be aware that some equations may have multiple solutions. In such cases, consider the context and choose the appropriate solution. Understand real-world meaning. Understand the physical or mathematical meaning conveyed by the equation and interpret the results in the context of the real-world situation. For example, here is an equation for converting between Celsius and Fahrenheit. C equals 5/9 times F minus 32. We want to solve this equation for F. Step 1. Start with the given equation. C equals 5/9 times F minus 32. Step 2. To create an expression for F, multiply both sides of the equation by 9/5. 9/5 times C equals 9/5 times 5/9 times F minus 32. On the right side, 5/9 times 9/5 simplifies to 1, so you get 9/5 times C equals F minus 32. Step 3. To isolate F, add 32 to both sides of the equation. 9/5 times C plus 32 equals F. So, the equation for converting Celsius to Fahrenheit is indeed F equals 9/5 times C plus 32. Now let's consider another example using the formula for the area of a trapezoid. The formula for the area of a trapezoid is generally expressed as A equals H times B1 plus B2, and then over 2, where A is the area, B1 is the length of one base, B2 is the length of the other base, and H is the height. To solve for B2 in terms of the other variables, you can follow these steps. Step 1. Start with the general formula for the area of a trapezoid. A equals H times B1 plus B2 over 2. Step 2. To remove the denominator 2, multiply both sides of the equation by 2. 2A equals H times B1 plus B2. Step 3. To eliminate H, on the right side, divide both sides of the equation by H. 2A over H equals B1 plus B2. Step 4. To solve for B2, subtract B1 from both sides of the equation. 2A over H minus B1 equals B2. Therefore, the equation for B2 in terms of the other variables is as follows. B2 equals 2A over H minus B1. Thank you.